Welcome again, wonderful Wildcats, to Monday, November 27th, Systems of Linear and Quadratic Equations on page 34. So if you would, update your table of contents. All right, now your table of contents over, let's take a look at our notes. All right, now you've solved systems of linear equations. Now we're going to solve systems of linear and quadratic equations. So we need to review some methods that we used in solve systems of linear equations and apply that to quadratic equations. Okay, substitution steps. Step 1, solve one of the equations for either x or y. Step 2, substitute the equation from step 1 into the second equation. Step 3, solve the second equation. Step 4, use the found variables in step 3 to find the other variables. Okay, so that's solving systems using substitution. Now let's look at linear graphing. Okay, so linear graphing. Standard form, when graphing in standard form, we know that ax plus by equals c. Slope, which is m, is equal to negative a divided by b. And the x-intercept is x equals c divided by a. And the y-intercept is c divided by b. Now when graphing in slope-intercept form, y equals mx plus b, where m is slope and b is the y-intercept. And a note, x equals number is a vertical line and y equals a number is a horizontal line. All right, so now let's look at quadratic graphing. Okay, now these are the directions for quadratic. We know negative 2, 4, negative 1, 1, 1, 1, 2, 4. Now we call them symmetric because negative 1 is 1 and 1 is 1, and negative 2 is 4 and 2 is 4. Okay, now the types of solutions when solving systems of linear and quadratic equations. One solution is when they intersect at one point, two solutions when they intersect at 2 points, and no solution is when they intersect at no points, or they do not intersect at all. Okay, so with that, if you would, finish up your notes. Now let's take a look at the examples. All right. Now, the front page is going to be review information, and then we're going to move into examples because we know you're coming back from Thanksgiving break, and we kind of want to reboot your Wildcat brains, and so you can get kind of more ready for this assignment. All right, so we're going to review graphing linear lines in review 1. Now, I'm going to use 3 different colors for the lines. I'm going to use yellow, green, and blue. You could use different colors, but you can use those if you want. So I'm going to graph the first line in yellow. Okay, let me zoom in a little bit so you can see it better. All right, now, first off, the number from the vector is slope, and slope is always a fraction. It's going to divide that by 1. Okay, here's our starting point, our y-intercepts. We start at 1, and our slope tells us we go down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, and then we go up 1, 2, 3 to the left 1, up 1, 2, 3 to the left 1, up 1, 2, 3 to the left 1. Okay, so that's reviewing how to graph when it's in slope-intercept form. Okay, now we know from our notes that if it's y equals a number, it's a horizontal line. So in this case, it's a horizontal line at 4. 1, 2, 3, 4. Okay, and then graphing in slope-intercept form. Okay, so first off, we're going to find the x-intercept. Okay, so we know the x-intercept is equal to c, which in this case, this is a, b, c. So c is negative 6 divided by a, which is 2, which is negative 3. So we know our x-intercept is negative 3, comma 0. So 1, 2, 3, negative 3, comma 0. Okay. Now for the y-intercept, we know it's equal to negative 6 divided by negative 3, which is equal to 2. So we know our y-intercept is 0, comma 2. So 1, 2. Now it takes 2 points to make a line, so we don't need to worry about our slope, and we have our line. Okay. And looks like we got two. Well, almost there. So a little good whiteout to fix that. All right. So now that's reviewing graphing linear lines. Now let's look at reviewing graphing quadratic lines. Okay. Now, same thing. I'm going to do 3 colors for 3 different lines. Now here we're actually going to graph, because this is the parent function, we're going to graph with points. Okay. So we're going to graph with x and y. So when x is -2, sorry, keep the color coordination there. All right, we know that that's -2 squared, which equals 4. When x is -1, we know that's -1 squared, which equals 1. When x is 0, that's 0 squared equals 0. When x is 1, that's 1 squared equals 1. When x is 2, that's 2 squared equals 4. Okay, so -2, 1, 2, 3, 4. -1, 1, 0, 0, 1, 1, 2, 4. All right, so now we're going to graph when it is in vertex form. Okay, so first thing we move our vertex. That means in B, we go to the right 1, 2, 3, 4, up 1, 2, 3, 4, 5. Okay, now we move the vertex. Now we graph by direction. And based on our points from A, we know our directions are -2, 4, -1, 1, HK, 1, 1, 2, 4. Okay. Now because of the negative, we multiply all the y values by -1. So that's -4, -1, -1, -4. So from the vertex, we go left 2, down 1, 2, 3, 4. Left 1, down 1. Right 1, down 1. Right 2, down 4. All right, now let's look at C. So remove the vertex. That means we go left 1, down 1, 2, 3, 4, 5, 6. And again, we graph by direction. All right, so we know our directions are -2, 4, -1, -1, +1. HK, 1, 1, 2, 4. But because of the 1/4, we have to multiply each of the y values by 1/4. So 4 times 1/4 is 1. 1 times 1/4 is 0.25. 1 times 1/4 is 0.25. And 4 times 1/4 is 1. So from this vertex, we go left 2 up 1, left 1 up 0.25, right 1 up 0.25, and right 2 up 1. All right. So that reviews graphing quadratics. All right, so now let's review factoring. All right, so it looks like in review 3, we're going to factor by the sum of cubes. Okay. Okay, so when we do that, we know that A is, we think to ourselves, I think I zoomed in way too much, sorry about that. There we go. All right, A is 2x because 2 cubed is 8 and x cubed is x cubed. And then B is 5 because 5 cubed is 125. Okay. Now this is in your notes, but I'm just going to write it down for you. But we know that when it's the sum of cubes, the form we use is A plus B times A squared minus AB plus B squared. Okay, so we know A is, that's 2x plus 5. A squared, so that's 2x squared. Oh, 2x squared minus 2x times 5 plus 5 squared. So we simplify, so that's 2x plus 5. 2x squared is 4x squared. 2 times 5 is 10, so that's minus 10x plus 25. All right, so let's review 4 factor. Now, in review 4, you're going to use the box method, the factor. Okay, now, for all you boxers out there that were unhappy with the time it took drawing boxes, I'm going to freehand these just for you. Okay, so we know first term, last term. Now we know that 2x and 1x make 2x squared. Okay, now we just need to find all the factors of negative 3. Well, that's 1 times negative 3, 2 doesn't work, and 3 times negative 1. So really, at this point, all you have to do is try each combination, see which one works to give you a positive. You want a positive 5x. Okay, so let's try 1 and negative 3. So 2x times 1 is 2x. Negative 3 times 1 is negative 3x. That does not combine to be 5x, so let's try negative 1 and a positive 3. Those are the only combinations really we have, okay? So 2x times 1 is negative 2x. 3 times is 3x. That doesn't work, so we can switch. So we can actually make this negative 1 and this positive 3. Okay? So then 2x times 3 is 6x. Negative 1 times 1x is negative 1x. They combine to be 5x, so our factored form is 1x plus 3 times 2x minus 1. All right, so let's look at review number 5. All right, now when there's 4 terms, you're more than likely looking at factor by grouping. Now, a factor by grouping, you factor out the greatest common factor. In this case, is 5. Okay, so if you factor out a 5, we're left with 1x cubed minus 1x squared minus 9x plus 9. All right, so now we're not going to worry about the 5. Now we look at here we can factor out an x squared, which leaves 1x minus 1. And then it looks like we can factor out a negative 9, which leaves 1x minus 1. Now you factor by grouping correctly if these two are the same, which they are. So now we have 5x squared minus 9 times 1x minus 1. Now the last step is you look to factor out the greatest common factor or factor difference of squares. In this case, the square root of 9 is 3. So this can be written as 5x minus 3 times x plus 3 times 1x minus 1. And I can put a 1 back in front of there. All right, so let's look at review 6 factor. All right, so in a trinomial, you go to the box method, and again, for all you box haters out there, I'm going to freehand this to save some time on the video. All right, so first term, last term, we know that x and x make x squared. Now we need to find all the factors of negative 24. So 1 times negative 24, 2 times negative 12, 3 times, and actually negative 1 times positive 24, negative 2 times a positive 12, negative 3 times a positive 8. And you really don't even need the positive sign. I'm doing that. All right, and then 4 times, let's see, negative 4 times 6, 5 doesn't work, and then negative 6 times 4. So now really you just have to figure out which combination gives you a positive 5, and that's right here, negative 3 and 8. So go through the check, negative 3x, 8x, they combine to be 5x, so this is factored, x minus 3 times x plus 8. All right, now that reviews a lot of the material we did the week before Thanksgiving. So now let's move into the examples. All right, solve the system using substitution. Now in substitution, it says step 1, solving one of the equations for either x or y. In this case, they're both solved for y. If they're both equal to y, they're equal to each other. So we have 1x plus 2 equals 1x squared. If you have an x squared, you need to move everything to one side and factor and solve. So in this case, we're going to subtract 1x and subtract 2 from both sides. Okay, so 0, 0, get 0 equals 1x squared minus 1x minus 2. Okay, at this point, we're going to factor. So draw a box. First term, last term. We know x and x make x squared, and so now we need to think of all the combinations to make negative 2. Well, that's just 1 times negative 2 and 2 times negative 1. So it's x plus 1, x minus 2. You get 1x, negative 2x. They combine to be negative 1x. So we have x plus 1, x minus 2 equal to 0. Set them each equal to 0. X plus 1 equal to 0. X minus 2 equal to 0. So x equals negative 1 and x equals 2. All right. Now you'll notice that example 2 is the same as example 1, except for it solves systems using the graph. And this was done intentionally so you could see how the solution looks by substitution, and the same system how the solution looks with graphing. Okay, so to graph, we know that that's the number in front of x is 1, but we can divide it by 1, so we have our slope. Okay, we start at 2, and slope says we go up 1 to the right 1, 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 so on. And then we go the opposite direction, down 1 to the left 1, 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 so on. All right. So now we have y equals x squared. And we know from what we did before, we have our points for that one, which are right here, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Okay. So xy, negative 2, 4, negative 1, 1, 0, 0, so on. Okay. So negative 2, 1, 2, 3, 4, negative 1, 1. That's a point of intersection. So we know one of our solutions is negative 1, 1. And then 0, 0, 1, 1, 2, 4. There's another point of intersection, 2, 4. So we see that it intersects twice, so there's two solutions. Now, the point of intersection is negative 1, 1, 2, 4. The solution is the x value from each. So the solutions are x equals negative 1, x equals 2. All right, so now let's look at example 3. And I apologize if the pen kind of, I guess, bled through, but I think we'll make it work. Okay. All right. So solve the system equations using substitution. Once again, we see that since they're both equal to y, they're equal to each other. So we have x squared minus 2 equals negative 2. Now, in this case, since we have just an x squared and a number, we can probably just solve. So we're going to add 2 to both sides. So you get x squared equals 0. Okay. Take the square root of both sides. So then x equals 0. All right. Now, you already know the solution to example 4 is going to be 0, but let's see what it looks like when you solve it graphically. Okay. So here, y equals negative 2 is a horizontal line at negative 2. Okay. Now, we graph y equals x squared minus 2. So we move our vertex at 0, negative 2, which is already our intersection at 0, negative 2. Okay. And then we graph by direction, which we know is negative 2, 4, negative 1, 1, hk, 1, 2, 4. So left 2, up 1, 2, 3, 4, left 1, up 1, right 1, up 1, right 2, up 4. And you can see here they intersect at one point, and that's 0, negative 2. So your solution is x equals 0. All right. Now, those are pretty straightforward up to this point, but now we enter craziness. Example number 5. Okay. All right. We see that they're both equal to y, so they're both equal to each other. So we set them equal to each other. So we have negative 6 divided by 5, x plus 9 equals negative x minus 4 squared plus 2. Okay, so we're going to solve. So we're going to multiply everything by 5 to get rid of the fraction. So that's 5 times negative 6 is negative 30 divided by 5, which is negative 6. Plus 5 times 9 is 45. This multiply is negative 5. X minus 4 squared plus 5 times 2 is 10. Okay? All right, so now we're going to need to distribute that x minus 4. So we have negative 6x plus 45 equals negative 5 times x minus 4 times x minus 4 plus 10. So really, we're not going to do anything else except for we're going to go ahead and multiply this. So that's negative 6x plus 45 equals negative 5. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16 plus 10. Now we need to distribute the negative 5. And before that, let's just start. Let me go back and get some lines here. All right. So now we distribute the negative 5. So then that's negative 5x squared plus 20x plus 20x minus 80 plus 10. Okay. Now we're going to add 6x to both sides and subtract 45. Okay. Cancel, you're left with 0 equals negative 5x squared and then plus 46x and then minus 115. Okay, so now we're going to factor. Okay, so we draw our box. And actually, one more thing, you actually need to factor out the negative. So you take away that box, sorry about that. And it's important, sometimes you forget, but you have to factor out the negative 1 first, otherwise it completely messes up your factoring. So we factor out a negative 1, so that's 5x squared minus 46x plus 115. Now we can draw a box. All right, so first term, 5x squared and 115. Now we know 5x and 1x make 5x squared. We need to find all the combinations to make 115. So we know 1 times 115. 2 doesn't work. And let me get a calculator. Two doesn't work. 4 doesn't work. 5 times 23 works. 6 doesn't work. 7 doesn't work. 8, 9 doesn't work. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 works. So really, the only combination that we're looking at is 23 and 5, because really 1 and 115, there's no way we're going to get 46, so that one's gone. So now we just try plus 5 plus 23. Well, that's 25x, 23x. That gives us 48. Close, doesn't work. So then we try the only other combination, which is 23 and 5. Well, that's 115x, and that's 5x. None of those comes to work, so this is not factorable. Whoa, there's a bell. All right, so that means we probably need to finish up. So now we see what not factorable looks like solving algebraically or substitution. Let's look at it looks like graphically. Now we already know that example 6 is a no solution. So let's take a look at what it looks. Let me zoom out so you can see side by side. Okay. So we graph, we start at 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We go down 6, 1, 2, 3, 4, 5, 6. To the right, 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And that should have been saying to the right 5. Okay. Now we graph. We move the vertex, so that means we move to the right. 1, 2, 3, 4, up 2, and then we graph by direction. All right, so we know -2, 4, -1, 1, HK, 1, 1, 2, 4. We multiply by -1. So that's -4, -1, -1, -4. Okay, so we go left 2, 1, 2, 3, 4. Left 1, down 1, to the right 1, down 1, to the right 2, down 4. And we see it's close, but we see that they do not intersect, so we know this is no solution. And so what we really need to add to example 5 is we'd actually say no solution. Okay, but I want you to see that if it's not factorable, then it's no solution. Okay, so with that, that ends the craziness, and y'all go about and have a wonderful Wildcat day.